Okay. So, again, what does the domain describe about a function? The what? X values. That's right, okay? Describes all possible x values. Well, I'm going to use this word. All possible inputs, okay, or x values, right? Because I don't say just x values here because sometimes we use a different variable, right? Like, for example, t is another variable that we often use when we write a function, t for time, right? Okay, so you just wanted to keep that in mind. It's not always just going to be x values we're describing, okay, of the function, I guess I should say. Okay. Sometimes when it comes to talking about a domain, right, we're not given, like sometimes we're given a function and we're not told what the domain is, right? In that case, we should just assume it's negative infinity to infinity. Okay. But here, in this case, right, we're going to be talking about identifying domains that make sense for our functions. Okay. And as we go through Algebra 2, you'll see that some functions, right, there are certain numbers we have to withhold from our domain. And you'll see why that is when we get to those points. Okay. Next, we'll define range or redefine range, right? Okay, it's the same definition as domain, except we switch one letter. Okay, same definition as domain, but what letter are we going to switch?
It's y value.
Yeah, x with y. Exactly right. It's y values. That's it. That's the same exact definition. Okay, it just describes all possible. Well, I guess 2 words, because I got to change the word inputs to outputs too. So never mind. I lied. Sorry about that. Of the function. Okay. The range will change more often than the domain, right? The domain is typically going to be negative infinity to infinity for a lot of functions that we look at. Okay. But the range will change more often. Okay. Something to give you a heads up on there. Okay, so let's do some. Here. So we'll just do an example or two here, and our directions here are going to be describe the domain / range of each. Okay, and we'll graph a couple graphs here. Okay. And we'll just sketch the graphs, okay? Nothing too crazy here. We'll just sketch the graphs. All right. Okay. So number 1 here, let's take a look. We'll do I'll put the function in red here. Something like that. So we'll say that's f of x. If you want to put little tick marks in, you can, but it's not really necessary here because we're not going to need them, I don't think. You can pretty much get the idea of what will be. Okay, so again, we're going to do the domain, we're going to do the range. And I'll just abbreviate with a D and an R there. Okay. All right. So, Liana, domain. Looking at this graph, right? Okay. What do you think? Can you give me the domain?
Negative infinity to positive infinity?
Yeah, negative infinity to infinity. Exactly right. Okay. When we go to look at our domain, remember that's the x values here, right? I'll put a little x above the domain there just so you remember that. Okay. And so we want to see how far left do we go, right? So if you kind of trace along your graph here, left, 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 you get to this arrow, right? The arrow is pointing up, but it's also pointing to the left as well. So we're going to not only go up, we're going to go to the left as we go out. And we're going to go further and further left, so it means we're going to go to negative infinity. Same thing happens with the right endpoint, right? As I trace along here, right, I get to this arrow, which indicates we're both going up, but also out to the right. And so we're going to keep going to infinity as well. Okay? So, there's that. All right, and then let's talk about the range. And we'll go to, oh, no Bobby today. Let's go to, oh man, someone who's here. Luke P. Luke P, what do you say, Luke P? What's the range going to be here?
I want to say that the range is going to be, it starts at 0,
Zero?
to infinity.
To infinity, that's right there, Buzz Lightyear. Okay, so do we get to 0 or no?
We get to 0.
We get to 0, right? So we're going to count it. And then, of course, we never can get to infinity, right? So we're just going to put a parenthesis there. Okay? So, yes, start at 0. Again, range, you're thinking bottom to top. Okay? Domain left to right, range bottom to top. So, Luke hit it nail on the head there. The bottommost point is at y value 0, and it goes up to infinity. Okay? All right, let's try another one here. All right. It's going to be and let's see, do something like this. Okay. That's fx right there. Okay. And again, we'll do domain and range. Okay. So, take a look at that number 2 there. What do you think about there for a couple seconds? You just sketch it out. Okay, think about it there. Think about what the domain would be. Leftmost point, right? What's the range going to be? Rightmost point. Or what's the domain would be, sorry, left to rightmost point. Range would be bottommost point to topmost point. Okay, so think about that. You got domains left to right, range is bottom to top. If you want to write that in your notes up here, right, you can think about that. Domain goes left to right, range goes bottom to top. If that's going to help you remember that, because that can be a helpful way to remind yourself, okay? Domain is always left to right, range is always bottom to top, okay? If you want to write that down for yourself, not a bad idea. Okay, well, let's go to someone here. Let's go to Chris. What do you say? Chris.
Many. Forgot the negative infinity.
Negative infinity to infinity. Very good. Yeah, again, that typical domain. Okay, if you're going to have to like guess a domain, that's a good domain to guess. Okay, if you're stuck, your brain just completely craps out on you or something like that, that would be a good place to guess. And in fact, it's right. As far left as we go, as far as right as we go, right? Arrows go both sides. So it's good. Okay. Now, how about the range, though? Do you want to do that one too, Chris?
That one, is it 0 to negative infinity?
Okay, so it does start at 0. That's correct. And we are going to go to infinity here, but that arrow's pointing up.
Oh, so positive.
So positive infinity. Exactly right. Yeah, so positive infinity. Yeah, very good. Are we going to get to 0? What do you think?
No.
No, yeah, so parenthesis there and parenthesis there. Okay. So this is kind of like that homework one that we saw, right? So Lindsay, again, same kind of example right here, right? It goes to 0, but it's not ever going to get there. All right, and again, it's kind of hard to see. I see what you're saying, because it's like, well, we're not really sure, right? Because Mr. Wynn, you didn't graph that, great, or whatever, you didn't draw it very well. But it is, in this case, we want to discount 0. Okay, or not count 0. Exclude. Okay, what you should not put here, what would be wrong, is if you put this. Okay? Without even looking at your graph, you should know that this is a wrong way to write the interval. Okay? Without even knowing what the graph looks like, if you just see this randomly on the street, someone's writing an interval out, you should know it's wrong. There's nothing that you need to know. Just looking at this, you should know that's wrong. That's incorrect, right? It's like seeing someone misspell something, you should know, oh, that can't be right. Okay? What's wrong about this? What's wrong about this? This is right. This is wrong. What's wrong with this interval? Without knowing anything else about the function here, why is this wrong? Peach?
And 0 is like less than infinity. So
Right. So, right, your interval should always have the smaller number here, the bigger number here. That's right. Okay. So if you're writing interval, okay, in your life, and you put the bigger number first and then the smaller number for an interval, that's incorrect. That would be incorrect. Okay. All right, let me give you guys one to try. So with that in mind, I want you guys to try this one. Here we go. Okay. So there's my function, and then there's the x and y axis. Okay. So tell me what the domain is here. Tell me what the range is here. Okay. Question. Can you do this one real quick, and then yes, unless it's an emergency. Okay. You got it? Okay. Well then, if you want to go, that's fine.
He said in the street, it sounds like they're in the same.
Yeah, exactly. Exactly. Yes. Exactly. Or sometimes I'll say in the wild too. Is this for this one right here? Okay. Okay. Domain's right. Range, you need to make a small correction though. Otherwise you're good at your sheet. Okay. Great job. Still trying out. That's fine. Okay. Doing okay on this hand so far?
Yeah.
You guys have a good starting point so far. Okay. Keep it up. Looking good so far there. Good. Domain so far is good. Domain's looking good there. Okay. Very nice work. Do we get to the 2 or not? Okay, we'll see. Talk about it. You want the yeah, see, yeah, correct. Yeah, understood. Right here? Yeah. Okay. All right. That's good. That's good. Yeah. I'll give you like 30 more seconds here. 30 more seconds to ponder it out. All right, let's go to Nick. Nick, for the domain. What'd you come up with here, sir?
Well, I got negative infinity, but I didn't know for the other one would it be also negative infinity? Like, is that?
Yeah, right. Because they're both kind of pointing down there. Is that what you're kind of saying? Okay, so I see what you're saying there. Yeah. So when we talk about, let's think about this, right? So when we talk about domain, we're describing x coordinates, right? X's go left and right. So the farthest left we're going to go. The farthest left, I go left, 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 left. I hit this arrow, which indicates we're going still to the left. So that's how we know we're going to negative infinity. The fact that this arrow is pointing down doesn't really matter to the domain, because I need to know whether we're going which way. If we're going to the left, how far out are we going to go? Well, we're going to keep going to the left, right? Same thing for the other side of the domain, right? We go to the right, 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 to here. Okay? This arrow, it's pointing down, but it's also pointing to the right. So what other x value are we going to
Infinity.
Positive. Exactly. Yes. And I purposely gave this one to you guys because it kind of like can be a little disorienting when you have these arrows pointing down like that a little bit. So yeah, that's the domain. Does that make some more sense now? Clear it up a little bit? Okay. So it's common, difficulty there. All right, let's go to somebody else here. Let's go to Luke L for the range here, sir.
I said 2 and then infinity.
2 to infinity, like this? Like that? Okay. So you've got some good numbers in there, all right? But we need to make a little slight adjustments here. So the range, right, describes what coordinates?
The y.
Y values, all right? And for y values, we're going to go from the bottom to the top. So what's the lowest y value our graph is kind of indicating here?
Infinity.
Yeah, but not positive. Yeah, there you go. Negative infinity. So negative infinity, comma, what's the highest y value our graph indicates? So I think you had the right idea, just like fine adjustments there, and you're on the right track. And we do get to the 2 there, so you want to put that as well. Okay? So you had the right ideas, just a little fine tuning. That's all you need to do. All right? Thank you for volunteering. Or thank you for answering, not passing. I didn't really volunteer. I voluntold you to answer. So anyway, questions on domain and range here? All right. So let's throw in one little other thing here. We're going to talk about end behavior. Okay, end behavior. What happens as you go to the ends or the extremes of your functions, or the end or extreme of your function? It's all right. Describes what happens at the extremes of your function. Okay. Describes what happens at the extremes. Okay. What happens as you go far to the right? What happens as you go far to the left? And the way we describe that, kind of like the main way to describe it, because it's not really an interval. Right, an interval, you're describing kind of starting point and stopping point. For an end behavior, you want to know what single value, what thing are you approaching as you go really far to the right, or what thing or number are you approaching as you go really far to the left. So it's not an interval, it's just going to be a single number. So it's not a range of numbers, it's just a single number. So here's what, well, in some cases you can have a range, but anyway. Here's how we're going to be describing domain. Here's how we're going to describe end behavior. We'll say as x approaches infinity. So x values approaching infinity means we're going really, 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 really far in which direction? To the right, because x is going to infinity, right? We'll put a comma and we'll say f of x, the y values, in other words, are approaching, and then blank. We're going to fill in a blank because that's going to change for different functions. And then as x goes to negative infinity, what's describing going which direction? X going to negative infinity was which direction? To the left. All right. And we'll say the function approaches blank. Okay? So the main thing we have to fill in are these blanks. What happens as we go? What happens to the y values as x goes really far to the right? What happens to the y values as x goes really far to the left? And we'll just do it for these functions up here real quick. Okay. That's what end behavior is. I'm going to kind of scoop that up here so you can kind of see. Okay. So, I think we can just kind of squeeze number 1 on there. as x goes to infinity. So again, trace along your graph here. As you go further and further and further to the right, what are the y values going to approach? As you go further to the right and keep going, right, what are the y values going to approach? Infinity, right? They're going to keep going up. So we go to infinity. And so that's what we're going to put here. I'll put it in red so it stands out, right, as there's our answer. We're going to go to infinity. Okay? As x goes to negative infinity. So now we're going which direction on our graph?
To the left.
On our graph, to the left. As we go to the left, left. Our y values are going to go which direction? To infinity as well. Yep.
Now why is that they go to infinity on the left side too?
So as we move along to the left here, Luke, right? As we move along to the left, we hit this arrow. It's pointing up. So the y values, right, are going to go up and up and up and up and up to infinity. Okay? So x is going to the left. X is going to negative infinity, right? We're going to the left. But the y values are still going to continue to go up because we hit that arrow. Make sense?
Yes.
Okay. Let's try number 2. As x approaches infinity, f of x approaches blank. As x approaches negative infinity, f of x approaches blank. Garrison, what do you think here? As x approaches infinity, so that means we're going in which direction? To the right. Okay. What are the y values approaching? As they go further and further and further to the right, the height or the y values of this function are approaching what number? 0? That's right. Yeah, it's 0. Okay. It's flattening out here towards the x-axis, right? So it's going to approach 0, not infinity. Okay. It's going to go. It's just flattening out. So it goes to 0. Okay. Very good, Garrison. That's right. Okay. You want to do the other one too, there, Garrison? As we go further and further to the left, what are the y values going to approach? That's it. Okay. Easy peasy, right? Try this one. I'll set it up here for you. As x approaches infinity, f of x approaches blank. As x approaches negative infinity, f of x approaches blank. Okay, so give that one a try then. Okay. Circle it for you. So for this last function that we did, go ahead and go with that. Okay. See what you can do. And as I'm walking around, feel free to ask questions about anything. Okay, yes, yeah, you're right. You got it. So, as you go farther and farther to the right, what are your y values going to approach? Right, we hit that arrow. Which way is it pointing? Down. So you're right idea. Just make sure you get the right sign for it. You're right here, Sam? Stuck on this one a little bit? Okay, so as x approaches infinity, you're going really far to the right, because infinity is this direction on the x-axis. So right, an arrow. That arrow is pointing to the right, but also down, right? So our f values, our y values, right? We're going to go down and down and down and down and down. So what numbers are going to approach as we keep going down, 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 down? Negative, right? Infinity, because we keep going down. That's right. Okay, same thing here. So now we're not going to the right, we're going to the left. So the left. We get this arrow, right? It's going to keep going to the left, but it's also going down. So then what's our y value?
Are you turning this in the office real quick?
Sure.
Yeah, it's just kind of change for it.
Gotcha. Oh, you're leaving team sports. You want to go to business management, huh? Okay.
Good for you.
Okay. Make sense? All right, folks. Okay, let's go to Tyler. So Tyler, what'd you get for your end behavior here?
For that one, I got negative infinity.
Negative infinity. As x approaches infinity, f of x approaches negative infinity. Yeah, as you go to the right, hit an arrow, goes down, negative infinity. Very good. How about for the left end behavior? Also negative infinity. Yeah. Okay. So, if you want to try and be like efficient in how you write this, right? One way you can actually sometimes you can kind of combine these things together. I mean, for example, here, one way we can kind of get away with this, you could say something like as x approaches plus or minus infinity, right? So in either case, if we're approaching positive infinity or negative infinity, we can write f of x is going to approach negative infinity, right? Because in this case, whether we're going to the right, positive infinity, or whether we go to the left, negative infinity, our function values will both approach negative infinity. So there's a way to kind of take both of these statements and put them together as one. Okay. It's hard to do when you approach two different ends, but you can do, if you want to kind of mix them together. Okay, questions on any of that? Right. Whew. So now we'll get caught up with the last couple little ideas I wanted to mention today, which are a little more vocabulary. Okay, so I know you thought you were done, but we're just done. But hopefully a little bit faster here too. So more function characteristics. Right? It's super important that you guys get down these basic ideas about, describing functions. Okay? Because we're going to be using these again and again and again. All right. So it's not something. Don't sleep on this. You want to be awake for this. You want to get it down. The sooner you get it down, your future self will thank you. Okay. Your future self will thank you if you can remember this stuff and get it down. Because we'll do this for every unit. We're going to be talking about all these different things. All right. So. Some other things we want to be able to describe about our function. We want to be able to describe increasing, decreasing, or constant behavior. Okay? How do we know if a function's increasing? Well, what do you guys think? If we want to know when a function is increasing, we're going to look for when the function does what? Goes up, yeah. But we want to be careful. It needs to go up from left to right. The function goes up from left to right. Here's why that's important. And maybe I'll draw a little sketch right here. Okay, I'll maybe draw it up in here. Okay. Okay, so there's x-y axis, and I'll draw like a linear equation here. Okay. If we just think about increasing as going up from left to right, you might look at this graph and say, "Oh, Mr. Wynn, I see this arrow is pointing up. It is going up. So therefore, this function is increasing." But is this function increasing? No. As I move from left to right, which direction are we actually going?
Down.
Down. So this function is what?
Decreasing.
Right. Okay. So please be careful here. Okay. When we talked about domain and range, okay, we talked about like domain and range of stuff. Okay, left and right. Right. We weren't talking there. We don't talk about moving left to right. Okay. It's a little bit so. I guess we do for the domain. We describe left to right. But anyway. So just be a little bit careful there, okay? Where there are like subtle differences there. Increasing, decreasing, and constant, you must be moving from left to right. And so then, whoops, you guys can fill in the decreasing one, I'm sure. This one we are really just changing a single word. Goes down. So increasing, if the function goes up from left to right. Decreasing, if the function goes down from left to right. What happens if the function goes up from right to left? What would that behavior be? I'm talking left to right, I'm talking left to right in both those definitions. But what would we describe it as if the function's going up from right to left?
Wouldn't it just be going down from left to right?
So that means it is what?
Decreasing?
Decreasing, yeah. So here's like a weird way, if you want to, like, think about it. This is decreasing. If the function's going up from right to left, right? Going up from right to left, we're going up, but we know that's a decreasing function. So likewise with increasing, how could I change increasing? It could be going up from left to right, or going what from right to left?
Down.
Down, yeah, okay. So it depends on the direction, right? But if that's confusing to you, I'm sorry, okay? I just really want you to, just focus on left to right, left to right. Okay, so then what does that leave us for constant? The function goes up from left to right, the function goes down from left to right. What does that leave us to describe with constant then? The function, what? Stays the same, exactly right. Very good here, so yes. The function stays the same from left to right. Okay? When something is constant, right, it is unchanging, immovable, right, or unyielding kind of thing, right? You might hear like that used in like song lyrics and stuff like that. I feel like I've heard that before. Okay, something that's unchanging. We use it in math, right? Sometimes we refer to the constant of a function. The constant number would be the number that doesn't have a variable attached to it, right? Variables change. Constants do not. So if you have a number like 2 and there's no variable attached to it, that 2 will not change. It will stay 2, right? But as soon as you attach a variable to it, it now becomes a coefficient, and it does change. Okay? Constant, unchanging. Okay, some other vocab. Maximum. Maximum of f is the highest point. A point is described using coordinates of f. That's slightly different than the okay. So the maximum of f, the highest point or coordinate, right? A point, you need x and a y coordinate. Maximum value, that's a single number, is the highest y value of f. Okay? So if you have your maximum of f, the coordinate, right, then you know the maximum value as well. It's just the y value, the y coordinate of that, the maximum point. Okay? And so then you guys can figure out what the minimum stuff is too, right? And then the minimum of f is the lowest coordinate, lowest point, right? And the minimum value is the lowest y value. Okay. Okay. Two more here. 0, slash x-intercept slash root. Okay? So in math, right, the 0, the x-intercept, and the root, those are all synonyms, right? A synonym is what? They mean the same thing, right? Different words mean the same thing. Synonym, okay? And then you compare that to like antonym, which are two words that mean the exact opposite thing, okay? But here, 0, x-intercept, root, these all mean the same thing, okay? And in this case, it is where f does what? To find a 0, to find an x-intercept, or to find a root. It's where the function graphically, what does the function do graph-wise? If we're looking for a 0, an x-intercept, or a root. It's where the graph does what? Cross the x-axis. Yeah, you got it. Crosses the x-axis. Okay? Or f of x equal to 0. All right, that's another way you can think about it too. When the function equals 0. Okay. All this stuff should be, hopefully familiar, reminiscent of things you've done before, like Algebra 1. Maybe it's been a little while since you've done Algebra 1, especially if you're doing like the 1 math a year plan. It's maybe been 2 years since you've seen Algebra 1, right? You took geometry last year, and then Algebra the year before that, right? It's maybe been a little while since you've seen Algebra 1, okay? But this is all stuff that's familiar from there. And then the last typical thing that will be asked, and this is going to, I guarantee you'll see questions like this again and again on your tests, okay? This will show up almost certainly, and it's average rate of change. Why is this such a popular question for them, to be asked? I don't know, okay? But like every function, every function, every unit, you'll pretty much have at least one average rate of change question, okay? And it's not mind-blowing, okay? The average rate of change, it's just the slope between two points on a function. Will you need to know the slope formula? Nope. I'll give you the slope formula. Okay? But you'll need to be able to interpret when you are asked to find the average rate of change between 2 points. That just means you need to find the slope between the 2 points on a function. Okay? What does this allow us to do? Okay? What this allows us to do is to find the slope of a function, or at least describe the average slope of a function. Okay? Because up to this point, right, what was the only kind of function that you could find the slope of? Up to this point, right, what was the only kind of function you could find the slopes of? Linear function, yeah, lines, right? We can do it for lines. Well, it turns out, okay, that we can approximate the slope of all functions by just picking 2 points on a function and find the slope between them. And then if you continue your study of mathematics and you get to calculus, you'll be able to find the slope of any function, the exact slope. Okay? And what I'm talking about here is, if you have like a quadratic function, okay, you'll be able to use calculus to find the slope of the function at this precise point, where you get like a slope just like that. Okay? The instantaneous rate of change. What happens at this instant? It's kind of interesting stuff. But for right now, we have to settle for average rate of change because that's the kind of calculation that we can do without having to go to calculus. Okay. So, let's do an example here together, and then we'll cut you loose for the homework and stuff. All right? So, all right. And I'll just do like the basic parabola here. We'll do x squared, okay? Our function for this unit is actually going to be the absolute value function. We'll get into that after the quiz. Okay, that's what we're going to be like looking at once you kind of get to this introductory stuff. We'll be really examining the absolute value function. So I'm going to put some tick marks here just to get a nice accurate representation of the graph. So 0, 0, 1, 1, and then 2 goes to 4. I won't make us do the domain and range for this. We already kind of talked about it, so that's fine. We are going to talk about increasing. We are going to talk about decreasing. We are going to talk about constant. We'll do the max value, the min value, and the zeros. And then we'll do the average rate of change. Of f from x equals 0 to x equals 2 as well. Here's a separate kind of calculation. Sorry. Thank you guys for bearing with me. I promise that we will try and give you guys time to work on homework in the future and stuff like that. I mean, we're running low on time here, but I'm trying to do that. It's just all this introductory stuff we got to get through. So hopefully tomorrow I'll have some time for you to do that. Okay. All right. So now we've got all that set up. Okay. Again, we've already talked about domain, already talked about range for this, so I'm not going to worry about that. We'll just start increasing. Is this function increasing? Is it going up from left to right? Anywhere? Yes? Okay. Where does it start going up from left to right? At what x value does it start going up from left to right? 0. Okay. So you're going to say 2 times 0? Yeah, 0 right here, right? Right here on the graph. All right, you can see that it starts to increase, right? So we're going to start our increasing interval at 0, comma, okay? And then from 0, if we continue to move along our graph, increasing, right? We're still going up, 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 up. We hit this arrow, which is going to continue to go up. So we increase from 0 to what? Infinity, right? We just keep on increasing. Okay? We know we put a parenthesis there for the infinity, but at 0, should we include 0 in the interval, or should we exclude 0 from the interval there? What's happening at 0? That's kind of like a tricky question. Okay, we're going to say at 0, we're going to exclude the 0. We're going to exclude it. Okay, and we can talk about that if you're like, if you want to argue about it, I'll be happy to talk about it. So we'll say if we're going to exclude the 0. Okay. All right, how about decreasing? Let me do this one. Let's do the easier one. Where do we stop decreasing? At what x value here do we stop decreasing?
0.
At 0, right? So that's going to be the right part of our decreasing interval there. Okay? Because we stop, so then 0 is the right endpoint, right? What about the left side? Where do we start decreasing? Right? We're going down, 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 down. Then we hit 0, right? The x value is 0 there. Where did we start decreasing? Negative infinity, yes. From the extreme left, right? From the extreme left, we're going down, 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 down to 0. Okay? So it's actually decreasing from negative infinity to 0 there. Are we ever constant in this graph? Are we ever constant? What do you guys say? Yeah, so if you want to be, like really picky here, we could say we're being constant exactly at 0. Okay, at the instant of 0, we would have a kind of a horizontal slope there. right? And then we start to increase, and now we'd have all these positive slopes here. So it's really your choice there. If you want to put x equals 0, that's fine. I'm also okay with you saying never, though, too, because typically when we describe increasing and decreasing a constant, we're looking for intervals. Since the constant would only occur at a point, then that's not really an interval, so you can say never there, too. But if you gave me x equals 0, I would be okay with that as well. So it's kind of your choice there, but I'm okay with saying not, never. Okay? Let's get maximum value for right now. Let's go to minimum value. What is the lowest y value that we see here on our graph? What's the lowest y value we see here on our graph? Not 1. Lower than 1. 0, yeah. Because you get down to the origin there. So notice for that minimum value, I just put y equals 0 because it's minimum value. It's the lowest y value. If you gave me the coordinate for the minimum value, I'd be okay with that too. If you gave me 0, 0, that'd be okay too. So if you put 0, 0 here, that's also okay, if you like. Now I skipped maximum, but let's go back to it. What's the highest y value here? 4, okay, yeah. We do have points at 4, but does our graph go higher than 4, Luke? That's part of our graph, right? That's part of our graph. Right? That's part of our graph right there. That goes higher than 4. So what's the highest y value here? Not negative infinity, because it keeps going up and up and up, right? The y values go up and up and up. So it goes to positive infinity. So when we talk about maximum value, we are looking for the highest point. But if we keep going up and up and up and up, do we ever hit the highest point? It just keeps going, right? So we have no maximum. We have no the highest point. It just keeps going. So in other words, we're going to say there isn't a maximum. Okay? A maximum means you hit the highest point and you stop. It's like you have a ceiling. Well, infinity has no ceiling, so there is no maximum value. It just keeps going up. Okay? All right, 2 more things here. Zeros and the average rate of change. Do we ever cross the x-axis? Or I should say, more importantly, do we ever intersect the x-axis? At what coordinate do we intersect the x-axis? We do. Zero, zero, that's right. Okay? Or you could just say x equals 0 if you like there too. So you give me the full coordinate or just the x coordinate there. All right, and then average rate of change. Okay, so remember, average rate of change, that just means the slope from x equals 0 to x equals 2. So the coordinate there for when x is 0, it's the point 0, 0. What's the coordinate for x equals 2? It's 2, comma, what's the matching y value at 2 here? 4, right? So it's 2, 4. And so you're just finding the slope between these 2 points. So 4 minus 0 over 2 minus 0. So you get 4 over 2, which is just 2. And so there's our average rate of change. Okay. Which makes sense, right? We're going from 0 to 4, right? You can see that's a positive slope, and we get a 2 for a positive slope there. Okie dokie. All right. Whew, we made it, folks. You made it through another day. And you're like, Mr. Witt, if all the days are like this, I don't know if I'm going to make it. Well, I understand. They won't all be like this. I hope not. I hope not, because I don't like it being this much either. Okay, here is your assignment then. Okay, here is your assignment then. Okay, so in section 1-2, okay, which is on page, I should probably get you the actual page numbers and not the wrong page numbers again. Okay, 1-2 on page 18 is the actual page number there. Okay, I would like you to do numbers 1 through 3. 7A and B. then 8 through 10. Okay. So that'll be your homework. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 problems there. Okay.
And this is in the online textbook?
Yep, it'll be on the online textbook. It's also available in your physical textbook that I gave to you guys. Okay. So use those. Any set requests for today? Any set requests for today? Anyone need something set?
Can you actually pull me?
Any other set requests?